Hey everyone, how are you guys doing? We're almost done. We'll wrap it up quickly. Just 10 minutes. Alright. So for those who don't know me, my name is Bharat Nair. That's how Americans call it. It's actually Bharat Nair. I'm an 11th grader in Prosper High School, and I am going to be talking about what is the compatibility between the ancient Hindu sciences compared to the compatibility with the modern science that we have today. Alright? So, let's begin. So I would like to start off by thanking Aasheervada Foundation for giving me this opportunity, and then we will move on to my overview. So first off, we begin with the ancient Hindu science's contributions and compatibility with modern science. So overview is, we're going to start off with scientists such as Aryabhatta, Bhaskaracharya II, Acharya Kannada, Acharya Charak, and Acharya Bharat. And we're going to move on to the fields of science that we've provided contributions to, such as physics, astronomy, engineering, biology, and chemistry. And I know, judges, there's so many other contributions provided, but gotta wrap up a 25, 30-minute essay to 10-minute presentation, so I'm sorry for that. But alright, we'll move on to the next part. We'll begin with Aryabhatta. I consider him one of the most important scientists or acharyas from our time. From 476 CE when he was born, he wrote a text on astronomy and an unparalleled treatise on mathematics called Aryabhatta. It's well renowned. We can still find copies of it today, although not exactly as accurate as I would like for it to be. But it was written in 499 CE when he was just 23 years old. So in one of his chapters called Ganatipada, in verse 10, it translates to add 4 to 100, multiply it by 8, and then add 6 to 2,000. By this rule, the circumference of a circle with a diameter of 20,000 can be approached. And notice the word approach. In Sanskrit, it's called ashano. And ashano basically means that it's approaching. So it's considered irrational. So this entire verse is actually talking about pi. And we got to pi to significant figures of 5 decimal places. And this is very key because the Western civilization was only capable of figuring out the irrationality of pi in 1761 by John Heinrich Lambert. And this is key because he was able to figure out a complex subject such as pi, even we're still confused on how it will end or what the numbers are going to be. He was able to bring it up to saying that it's immeasurable, it's irrational, and it only approaches to a number and never reaches that number. And that's very key. But also, he was the first to proclaim that the Earth is round. It rotates on its axis, orbits the sun, and is suspended in space. This is thousands of years before Copernicus was able to bring this into the Western civilization. And even when he did, he was scorned for it. But I'll get to that later on in that presentation. But next, Aryabhatta is also known as a master astronomer because he was able to bring in 0. The number 0 was given to the given credit to the Indians, ancient Indians, by a person named Ibn Battuta. He was able to say, he was an Arabic traveler and scholar. He said, we are able to credit the number 0 to Indians because of Aryabhatta and the text that Aryabhatta had wrote. And he's a colossus in the field of mathematics, and without it, the computer technology and the binary system would be virtually non-existent. So he was also able to give lots of approaches in trigonometry and calculus, but those are well known, and I have it more on my link of my paper, and you can read about all the calculations there. But next, we'll move on to Bhaskaracharya II. He was born in around 1114 CE, and he's considered a genius in mathematics because he was able to bring in gravity way before Isaac Newton was. In one of his verses on the book, he talks about objects fall on Earth due to a force of attraction by the Earth. Therefore, the Earth, planets, constellations, moon, and sun are held in orbit due to this very attraction. This is the basis of gravity and its ancestral rule that is brought in by Isaac Newton later on, 500 years later, in the Western Empire. His work also sparked scientific thought in the Persian and European empires, which is also very key, because those are the main empires that were able to develop lots of languages and scientific thought and move into the Renaissance period. But next, we can talk about Acharya Kannada. He was born in 600 BCE. BCE is a translation for before Common Era for those who don't know it, because they try to make it more assimilating by not saying before Christ. But anyway, BCE, founder of the atomic theory, he classified all the objects of creation into 9 elements: earth, water, light, ether, time, space, mind, and soul. He advanced the system that also includes space, time, matter, as well as observers. This statement of his ushered into the atomic theory because he was able to say that there's something more prevalent and more deeper into the thoughts of each object in our society and in our universe. He was also able to theorize that there are 4 types of atoms, 2 with masses such as protons and electrons, and 2 without them, known as neutrinos and photons. Although we know there's some more of those. Right now, we're talking about how so long ago we were still able to determine such a clear and precise thought without the current technology. Next, we can talk about Aasheervada. He is known as the father of medicine because his renowned work on the Charak Samhita, which is considered as an encyclopedia of Ayurveda, which has over 100,000 uses of herbal plants. He was also able to cure, retain their potency and truth, and even after a couple of millennia, he was able to figure out the nature is the best fix for any kind of disease that humans ever get. He was also able to prove that when the science of anatomy was confused in Europe, Aasheervada was able to reveal through his innate genius and inquiries about the facts in human anatomy, embryology, pharmacology, blood circulation, and diseases like diabetes, tuberculosis, and heart diseases. He was able to create now the Western civilization we call primitive side of healing in order to show that our ancient civilizations were not only capable in science and math, but they were also able to bring in medicinal fields. And it's very key to showing that now Western civilizations actually look at Ayurveda as one of the most prevalent and most prominent sciences that are brought out of the ancient Indian civilization. But next we can go on to Aasheervada. He is a pioneer of aviation technology. He authored the Yantra Sarvasa, which includes the astonishing and outstanding discoveries in aviation, science, space science, and flying machines. He has described 3 categories of flying machines. One that flies on Earth from one place to another, planes. One that travels from one planet to another, spaceships. And one that travels from one universe to another. It seems that even Western civilization is still not able to capable of trying to figure out a different type of machine that can actually go from one universe to another. And that's because our ancient gurus and munis were able to actually figure out different laws and mechanics that the Western civilization, with they're only going through logic and perception, is not able to identify. His designs and descriptions even impressed and amazed aviation engineers of today due to his brilliance in aviation technology. So the unfortunate aspect of this is that many of these texts and knowledge were lost for many years before they were ever rediscovered. But these scientists aren't the only contributors to ancient Indian science. Many anomalous statements in Indian texts whose origin is not understood, such as the correct speed of light, the correct distance to the sun, cosmological cycles, the fact that the sun and the moon are approximately 108 times their respective diameters, the approximate number of species on Earth, and so on. I'll get to the first couple of them later on in my presentation, but also modern historians either ignore these claims about our having these knowledge already, and by just saying no, they're not facts, or they just say that they're mere coincidence and because they have no logical backings to it, which we need to figure out later, because I look over this more in my paper, because the fact that we're considering all of these as just coincidence is just a big problem in today's society. But now let's move on to ancient sciences. Let's start with physics, because we believe physics is one of the most important things when we're trying to figure out an entire universe, beginning and end. So, in the beginning, Indian physics don't appear to have helped European scientists in their process of discovering their physical laws. The key idea needed to further develop was the idea of the observer. We talked about how Aasheervada brought it. This key idea of observer was necessary because without this, there would be no possible way for us to take another point of view, another perception, in order to try and figure out the nations of physics. There are also many other ideas such as the origin of matter recorded in ancient Hindu texts. So there's Taittiriya Upanishad, there's talk about the origin of matter. And one of the key verses that you have to look at is from the 6th century before BCE is that from absolute cause, the space came, from which wind came, from wind, fire came, from fire, water came, from water, earth came. Modern physics has the sequence as plasma, which is space, gas, which is wind, energy, which is fire, liquid, which is water, and solid, which is earth. So there's already a key correlation between our ancient Hindu sciences and physics compared to modern science. So topics discussed in ancient Indian texts such as the Rig Samhita is the speed of light. I talked about the exact calculation in my paper, but if you look at it, it talks about that it is remembered that the sunlight travels 2,202 yojanas in a half of a nimisha. The calculations are provided in the paper and basically says that there's 186,282 miles per second. There's a slight difference between the two values can be formulated through error and inaccurately translating from Vedic science to standard units. The Brihat Samhita in 6th century approaches the idea that the rainbow is created when multicolored rays of the sun is being dispersed in a cloudy sky or seen in the form of a bow. Let's move on to astronomy. In astronomy, we were able to bring in the heliocentric idea in the Taittiriya Samhita in 528 BCE. The universal law of gravitation was propounded by Isaac Newton much later. The Rig Veda in 5000 BC approximately also discusses this further when it says the elliptical path through which all celestial bodies move is imperishable and unslacking. This was formulated some 7,000 years ago by the Western astronomical traditions up to age of Copernicus believed that the planets and other celestial bodies had circular orbits. So in the Aryabhatiya, it also covers the eclipses and not circular motions. It also formulates the moon as a satellite of the Earth, that rotates, revolves around the Earth, and also revolves around the sun. The Surya Siddhanta calculates the circumference of the Earth to 4.008107 meters, while modern science calculates to 4.0075 times 107 meters. That is very close to the estimate of recent calculations. Engineering. In engineering, we can talk about the Vimana Shastra, which is a great archaeological blueprint that's been found a couple of years back that shows that there's an easy way for us to actually implement flying machines. But we can also go on further and talk about the engineering facts about the Iron Pillar in India. It's an iron pillar and still hasn't rusted thousands of years later. This shows that the engineering and metallurgy of India is far superior to the Western civilization at that time. The mythology of the grammar rules formulated in the ancient grammarian Panini in his treatise Ashtadhyayi helps modern linguistic studies show that the recent NASA even confirmed the structure of grammar in Sanskrit is most correlated to artificial intelligence. So when modern scientists take this into account, we'll be able to figure out artificial intelligence into a much higher level. Chemistry. In chemistry, we can talk about how the main piece of Hindu text on chemistry was written in 900 CE called the Rasarnava. This book describes the process of distillation through using pots and fire, the flame test, the resistance of metal to corrosion, as well as the extraction of mercury using the process of sublimation. It also talks about salts and different types of salts and how to create explosives. And this was a couple of thousands of years before modern civilization was able to catch up to this. Biology and Ayurveda. This is one of the biggest branches of science that is actually capable of bringing into modern sciences. If you look at it, medicine is not just surgery, but it also includes specific steps and details into plastic surgery of the nose, doing intestinal surgery from large blockages in the kidney, as well as documented that the Chiksasan was written in 500 BC. So, what does this mean to us in Western/modern science? When we look at all these different inventions and discoveries and studies from ancient India, we're able to realize this is only capable due to the flexibility from the society and the religion. In the Western world, however, the scientific pursuit is always disputed by the religion. Copernicus, instead, when he brought in heliocentric idea, he challenged the church, and that caused Copernicus to be put into trial. Same with Galileo, when he actually propounded the fact that Copernicus was correct, he was put under house arrest. So these show that Western science had issues with compatibility between religion and science, whereas the ancient Indian civilization were capable of drawing a line, while at the same time not to contradict each other's existence. So in conclusion, the technology and practices from ancient world were lost for many hundreds of years due to colonization and conquering of Indian lands. Yet, it is basically shown that the Hindu science were able to draw a line between science and history, and that was a key propounded in trying advancement of science in ancient India. Thank you. And you can see the rest of my paper in that URL. Thank you everyone for listening. Sorry about the time.
Thank you. It's a very informative paper. I want to add two informations. One is about that the excavation took place in Adichanallur in Tamil Nadu. They were able to identify an IO site in which, based on field dating, thermonucleus dating, we were able to find out that ancient people, they were able to use, using arsenic technique, and they were able to use and manufacture swords which are more powerful. These swords were exported to Alexandria. We have the evidence from Archimedes.
Yeah, I actually have that in my actual paper.
Very nice. Thank you.
Very nice. Because it showed how they were able to propound on bronze and steel.
Sure.
And they combined them to form the most strongest type of swords you can ever find.
The only thing is, all these you can add some latest information also. For example, another one talking about the discovery of zero, or invention, whatever. So we have an evidence from Lakshari inscription, which we have seen. It is dated to 3rd century AD. The earliest reference to zero used by the Indians as a placeholder. So it is done by the Oxford University. It's also published in Nature. So these things you can add so that we have an evidence to prove that whatever you say is correct. Anyway, thank you for your input, sir.
Thank you so much.
For astronomical calculations, also please look at the Mahabharata. I'm sorry, I'm sounding like a broken record here. When Bhishma is asked to calculate whether the Ajnatavasa of the Pandavas is finished, he gives a very detailed knowledge of calculation of astronomy and stuff. So way before Aryabhatta, we already in the Mahabharata have great evidence for astronomical study and speculation.
So I have just one question on the Mahabharata tangent line, right? So I know you're supposed to ask me a question, but I just want to understand it. Right? Okay, so if we are to bring in Mahabharata into a research paper, like, would that cause problems with like studies or like the credibility per se? Because like you're bringing in like somewhat of religious text into a scientific Vedanta, would that be a problem, or because you have experience on it? That's what I was wondering.
I don't think there's a problem with reading the Mahabharata in a plurality of ways. I don't think that, yes, it is definitely a scriptural text, it's a legal text, but that does not rule out that ordinary experience or facts are narrated in it. So I don't subscribe to that distinction between religious and secular literature at many levels. I have a related point to make. There's a huge distinction when we say Western science and modern science. Those are two very different things. Modern science really arises in response to a very specific situation. It's not really relatable to the traditional science that precedes it. There's a complete transformation in the worldview. There's a transformation in the understanding of how humans relate to the world. And there's specific philosophical changes that now make the entire world appear calculable, knowable, and that gives rise to modern science. So I would make that distinction. You sometimes said Western science / modern science. I would make that distinction. And secondly, as concerns Western science itself, that itself is a story that the nation states of Europe hold themselves. They claim the whole heritage of antiquity and said there's this unbroken tradition of rationality, science, human freedom, democracy coming down from Greece to us. And therefore we are the inheritors of this tradition which no other part of the world had. Well, it wasn't all your heritage. They weren't all Western. And you cannot claim that in that heritage. So even the concept of an unbroken Western science really has to be subject to criticism. And there are specific sort of scientific achievements in specific places at a time. But Greek thought is as much Oriental thought, and Greek philosophy is as close to religion as any other. It's in the 19th, 20th century that this break is made between Greece and the Orient. Orient is the place of irrationality, Greece is the legacy of the West.
Thank you so much.
Continuing Professor's opinion, Dr. Narahari Hachar of University of Memphis, he was using the NASA's planetarium software, is able to identify most of the dates of Mahabharata events using the astronomical. So it's very interesting. I mean, you cannot dispute him immediately in the sense, though it's occurring. For example, he said that Krishna's departure from Dwaraka to Revati, September 26, 3067 BC. Krishna's arrival in Hastinapura on Bharani, September 28, 3067. So he revised this and recently published also his paper. That's also this application of modern science to prove our heritage. Thank you.
All right, thank you so much.
I have a couple of comments, to your excellent paper. Congratulations again. I'd like to point out some examples. You mentioned Panini. So Panini's Ashtadhyayi, the semantics that he discovered, and the way he described the Sanskrit grammar. Of course, he was not the originator of Sanskrit. I mean, Sanskrit had already been coming for almost 3,000 years before him. He basically codified the rules of Sanskrit grammar. And so the semantic, the way he set it up, in the modern times, the same thing was rediscovered by the computer scientist by the name of Backus. He was a professor in one of the American universities. So what Backus, came up as what is called as algorithmic languages and linguistics. So then it became known as Backus normal form. And later on, people pointed out that his form was, his semantic was exactly the same as what Pawnini had already done 2,600 years before him. So now it is called as Pawnini normal Backus form. So one of the responsibilities we Indians have, that we need to go back wherever the Westerners have appropriated our older concepts and assigned them their own names. We need to go back and fight with them and establish our own criticisms. For example, I'll give you another example. Acharya Jagdish Chandra Bose, he is the one who came up with the concept of telecommunication. And he basically, he was a well-known physicist in his time in the early 1900s. He was going around in a European universities giving lectures. And Marconi, the Italian guy, actually, got the idea from his lectures. And so for a long time in the Western, history, they kept talking about telecommunication as it is coming from Marconi. But now, in the last 10, 15 years, the Indians have fought in AAA, and now it has been established that it is Acharya Jagdish Chandra Bose who was actually the father of telecommunication and not Marconi. So the reason I want to bring this out is that we Indians need to fight for all of these concepts that we originated and have been appropriated by the Westerners and Western modern science. And the examples you gave are great. And also, I think it's wonderful for us to recognize that what our ancient rishis already knew. And we should not forget also that Europe was actually a dark continent until the plague of Europe, 1350 AD.
Until the Renaissance, right?
Yeah. The Renaissance started because part of it is the whole inspiration for Renaissance to Europe. They claim that it came from the Arabs, and the Arabs got their inspiration from us, the Indians. So, and also at the same time, these church leaders were coming to India. When Vasco da Gama came, and even before him. So a lot of some of these Indian ideas were actually transmitted through these Jesuit missionaries back to Europe, and they all constituted a part of the European Renaissance. And so what we have to think about how the European Renaissance was actually dependent upon the concepts that came from the Indian subcontinent which traveled to Arabia, because of the Muslim invasion in the 1100 century, and then progressed onto. So, for example, the Europeans call the Hindu numbers as Arabic numerals, because they learned it from the Arabs. Whereas the Arabs itself call them as Hinsa, meaning derived from India. So all of this, we need to relook at the entire history progression that these Westerners have tried to propagate as if it originated in Europe. And also this whole concept of pi, so let me ask you this, why is pi so important? Why do you think pi is so important?
Well, without pi, we couldn't get the figure of ellipses and circular motions and that kind of stuff. It's a profound foundation for physics and circular physics as well.
So pi comes in as a ratio between the circumference of a circle and the diameter of a circle.
Yes.
That is how the term pi comes.
Yes.
And that is why it is so important, because we cannot talk about astronomical bodies without understanding the circumference and the diameters. The simplest shape is a square or a circle. And that is, so that is why it was so important. And also, we should keep in mind that in our Indian system, we always call the word as Bhugol from very ancient times. Bhugol. Prithvi is gold. So we had a very ancient concept going back, and I think, our scholars here will tell us when this term Bhugol came about in our system. So Bhugol, we already knew that the earth was not was round, as opposed to the Europe in the 14th century, they were still talking about the earth being flat.
Yeah.
In fact, when, the Columbus, when he came to America, he was trying to hope for, he was thinking he was going to fall in the abyss. And so these concepts were already around, and we already had these terms, Google, actually they borrowed the term trigonometry. Trigon was the triangle, that is how they came up with the word trigonometry or geometry. So thank you very much for your presentation, and I think if you continue to research, you can do a lot, add a lot.
Yeah.
Our understanding.
Yes. One more thing, I totally forgot to give my paper to you, but sometime I'll give those papers to you. Thank you so much.